This changes everything. AGI is coming tomorrow. There are no jobs by the end of the year. And now people are like, why is it so slow?
Well, AGI completely overturned the software industry. It's moving at breakneck pace, and there's some news that's got everyone buzzing. A new advanced level open source software engineering agent just dropped, and it's a game changer. What's amazing is that not too long ago, Devin, the first autonomous software engineers, shocked the industry. It was a big deal because it was the first time software could build itself without much human help. Now, this new agent is set to turn the tech world on its head. So here's the announcement. This agent, called SWE Agent, is our new system that can automatically fix problems in GitHub repositories. It has accuracy similar to Devin, another software engineering tool, and takes about 93 seconds on average to get the job done. It's open source, meaning anyone can use it and make it better. We also made a new interface to help GPT-4, the AI model, easily edit and run code. First, this new system is open source, which means anyone can use it and see how it works. That's a big deal because it allows more people to contribute and improve it. Looking at an open source benchmark, this system scores 12.29%, while Devin, another similar system, scores 13.84%. Even though it's slightly behind Devin, it's still pretty impressive, especially because it's completely open source. But why is this such a big deal? Well, remember Devin, the software engineering agent that was open source and got $25 million in Series A funding? That's a lot of money, but now, a small team of open source devs has managed to achieve similar results in a much shorter time and a lot less money. Here's something else that's interesting. There's not a huge gap between these two models. There's just about a 1% difference, which means they're almost the same. Because of this, it'll be exciting to see how future models improve with more resources and better tech. As new versions come out, like GPT-5 or improved versions of GPT 4.5, we might see even better performance and more advanced capabilities. Point number 2 is that in Devin's benchmark, the other systems were way behind in terms of performance, but if you look at the new benchmarks with this new open source system, you can see that it's almost caught up to Devin's level. This shows that open source projects are closing the gap with the top closed source systems. This shows that open source models might be catching up to, or even outpacing closed source models in terms of what they can do. The reason open source is catching up in the benchmarks could be that both open source and closed source models are based on the same tech, like GPT-4 or Claude Opus. These base models have strong planning and coding skills built right in, which helps them achieve similar results, whether they're open source or not. Let's talk about point number 3. How does the software engineering agent work? Well, it interacts with the special terminal, which lets it open files, scroll through them, and make edits. It can also correct specific lines of code and check for errors automatically. Plus, it can write and run tests to make sure everything works as expected. The custom interface is key to the agent's good performance. And here's what happens. The software engineering agent uses a special terminal to help it think it through its steps. When you watch the demonstration, you can see how it plans its tasks and checks its progress. It does this by showing its thoughts and actions, followed by observations, where it checks if what it's doing is making sense. For example, it might notice that in the production script, the maximum and minimum values aren't being converted to R. This way, it can catch and fix issues while it works. It starts looking for files related to R code generation. And after searching, it checks its observations to understand the data it found. Then it generates a thought and follows it with an action. For example, the system might think, the responsible file code is probably here. Let's check it. Then it takes an action based on the thought. After the action, it goes back to observing to see if everything's on track, and repeats the process. In point number 3, it's all about its process. It thinks, then acts, then observes what just happened. After that, it thinks again, and the cycle repeats. The interesting part is that this open source software agent seems to have the ability for long-term planning, or at least it can adjust its plans as it goes along. This makes it a flexible tool that can adapt to different situations and keep improving as it works. Point number 4 is really interesting because it shows something unexpected. The key takeaway here is that there's a new design involved. Just connecting a language model, or LM, to a regular bash terminal doesn't work well. What we discovered is that language models need carefully designed interfaces to function, effectively kind of like how people prefer user-friendly designs. For instance, when the LM messes up the indentation, our editor catches the mistake and provides feedback to fix it. This makes it way easier for the LM to do its job without causing issues. The main point here is that the LM needs a agent-computer interface that's user-friendly to work effectively. Connecting it to a basic bash terminal just doesn't do the job. So they've created a new interface specifically designed to work well with language models, ensuring that they understand what's happening and can be more effective. This new design has an environment that provides feedback to the agent, allowing it to function better. Point number 5 reveals something interesting. They decided to limit the information given to the AI system. They found that it worked better when they let the software engineering agents view only 100 lines of a file at a time, rather than 200 or 300, and definitely not the entire file at once. This suggests that they didn't want to overload the system with too much information, allowing it to focus on smaller sections for more effective completion. The task they set for the system was to view just 100 lines at a time. They found that it was better than letting it see 200 or 300 lines at once. I think this is because having it more lines made things more complex, possibly confusing the model. By keeping it to 100 lines, the model could focus better and process what was happening more easily. It seems like the internal system, or internal agent, works better when it has fewer things to focus on. And this isn't too surprising, but you might expect that giving an agent access to the whole file would help it work better. However, limiting it to 100 lines at a time might actually allow it to plan better and be more effective. It can focus on a smaller chunk, which might help it understand and complete tasks more efficiently. When you limit the software agent to only viewing 100 lines at a time, it can focus all its computing power on making sure it does things correctly. And good design for the agent's interface becomes even more important when using advanced models like GPT-4. So if you're building a high-level AI software engineering plant, you might find that restricting it to 100 lines could be more effective than allowing it to see 200 or 300 lines at once. This way, it can concentrate better and make fewer mistakes. Point number 6 is quite interesting. The software engineering agent can be easily adjusted and expanded, which is great for future research on software engineering agents because it's open source. Anyone can experiment with it and suggest new ways for the agent to work with computers. This is exciting because it means that the development of the system could move even faster, thanks to contributions from a broader community. Point number 7 is that it provides a link to the demo where you could see how this advanced software engineering agent works. This demo lets you try it out for yourself, which is pretty cool. In point number 8, they mentioned a paper release. A lot of people are interested in the technical details, so they announced on Discord that they plan to release the paper by April 10th. The paper explains how the system works, including all the benchmarks they used and whether they were open source or closed source. It will also cover how they fine-tuned the system. Oh, and some of their early experiments that show what worked and what didn't. The full paper is expected to come out next Wednesday, where you can get all the details and understand the process even better. Point number 9 is about how much it costs to run the system. You probably know that AI systems need to perform many different reasoning steps that can be expensive because they generate more tokens, basically more data compared to simpler tasks. What's interesting is that they cap the cost at $4 per task, but they usually spend much less on each task. Could open source catch up to closed source? Let us know your thoughts. Hit the like and subscribe button if you found the video helpful as well.